Hello everyone. Assalamualaikum warahmatullahi wabarakatuh. We meet again at Food Technology Study Program, Department of Food Science and Technology, Faculty of Agricultural Engineering and Technology, IBB University. Welcome back to ITP 322 Food Safety and Sanitation course. We have been meeting for 7 weeks before, and today we are going to discuss our 8th materials on sanitary design for building and equipment. My name is Rati Dewanti. I'm a professor in food microbiology at IPB University. Today's topic will cover the definition of sanitary design, sanitary standards, classification of sanitary designs in regulation, and 11 principles of sanitary design for building and facility, as well as 10 principles in sanitary design for machinery and equipment for food industries. Upon completion of this lecture, you are expected to be able to define sanitary design in food industry, describe 11 principles in sanitary design for building and facility in food industries, as well as describe 10 principles in sanitary design for equipment in food industries. Let's begin with sanitary design. Sanitary design is the application of design techniques that allow cleaning of all manufacturing assets to be done appropriately in time and effective. This will include controlled traffic of ingredient, GMP, clean, dry, no gap floor, sanitary building and equipment, effective sanitation procedures to achieve food safety objectives. There are several institutions that establish guidance on sanitary design. USDA, through the FSIS, developed guidelines for the design of the plant, equipment, and machinery and other facilities for meat, poultry, and egg processing. And US FDA, for example, developed requirements for cleanability of plant, machinery, and equipment for food processing. The following list include other institutions that develop sanitary design for certain commodities. There are several types of sanitary design. Sanitary design for building, for utility, for food processing equipment and machinery, for cleaning and sanitizing, and for personnel. For today's lecture, we are going to cover sanitary design for building and facility, as well as sanitary design for food processing equipment and machinery. In Indonesia, sanitary design is incorporated in several good manufacturing practices guidelines. Uh, for example, the Ministry of Industry Regulation number 75, 2010 on the guidelines for GMP. And then another one is the head of BPOM regulation on GMP for home industries, regulation of the head of BPOM for the guidelines for powder infant formula and powder follow-up formula, as well as regulation from the Ministry of Health that regulate the hygiene and sanitation for food services. There are 11 sanitary design principles for building and facility. They are listed in the slide, and I will discuss it one by one in the following slides. The first principles, there are distinct hygienic zones established in the facility. Food processing building or facility must have hygienic zones that is physically separated from other zones. This differentiation can allow one processing in a chain to be conducted while the other has a problem or is being dedicated for cleaning, etc. Zoning also allows raw materials and personnel traffic appropriate for the flow of processing while minimizing the potential for cross-contamination. An example for this is the physical barrier between raw and processed food. This graph shows you a very distinct separation between one chain of process to another that will help to maintain the sanitary condition. The second principle is the control of the movement of personnel and materials flows to reduce hazard. Based on the first principle, when plant is divided physically into distinct zones, the traffic for materials as well as personnel can be designed such that hazard could be better controlled. Traffic of workers, visitors, products, raw materials and ingredients, and packaging materials has to be designed carefully to ensure they move from one zone to another and avoiding or decreasing risk of contamination. To implement the second principles, one can use passive barriers such as shown in the left picture or an active barrier as seen in the right picture. The third principle is regarding the water accumulation that is controlled inside the facility. While water is essential for product processing and sanitation, it is also an important threat to food safety. Construction of walls, floors, ceilings has to be designed well to prevent puddle and shall be designed to facilitate self-draining and water disposal. Floor generally has to be made from strong and durable materials with slope to facilitate draining and equipped with good dryness. This is a picture of a well-designed floor that allows self-draining. The fourth principle requires that room temperature and humidity are controlled. Room temperature and humidity is important in controlling microbial growth. They need to be cool and dry. Therefore, it has to be ensured that heating, ventilation, and air conditioning system is able to maintain temperature and humidity, and the engineering division has to assure that this HVAC system could control environment and the plant has to consider that machine and equipment are running. The fifth principle requires that room airflow and air quality are controlled. The HVAC system especially has to assure that airflow only takes place from cleaner to less clean rooms. Air entering processing room has to be filtered, and the supply of backup air from outside room to maintain flow rate and pressure at specific room must be available, and minimum condensation at open surface. The sixth principle requires that site elements facilitate sanitary condition. When choosing location for food processing facility, one should consider the availability of the yard, lighting, water, to make it possible to carry out cleaning, sanitation, and maintenance of building and equipment properly. They have to make a consideration in terms of access control to and from the location, and starting from the design of the construction, will have to be carefully consider the security aspect of the location and personnel, good vehicle management, lighting, such that the site is conducive not only for food safety, but also for the safe and health of the worker. Seventh principles requires that building envelope facilitates sanitary condition. During the designing and construction, one has to assure that all openings in the building are free of insects and other pests. All openings have to be designed such that they do not provide shelters, they do not become entry routes for insects and other pests, and facilitate cleaning as well as inspection. Eighth principles requires that the interior spatial design promotes sanitation. The production line shall be designed with full consideration for food safety. Adequate interior space has to be held to allow cleaning, sanitizing, and maintenance of the building components and processing equipment in accordance with good procedures. Principle number 9 requires that building components and construction facilitate sanitary condition. When designing building components, we have to prevent locations that could be used as hiding place, thus the source of contamination. When choosing building materials, always seek materials that are durable and resistant to chemicals commonly used for cleaning agents. Attention shall be made for floor surfaces, wall and ceiling finishing or coatings, and utility ducts that penetrate the wall that may become a source of contamination. Principles number 10 requires that design of utility system prevent contamination. When designing and constructing utility installation, always pay attention to prevent the occurrence of hazard by assuring all surfaces can be cleaned to the appropriate microbiological standard. We will discuss this later. And choosing as well as using the appropriate construction materials, providing access for cleaning, inspections, and maintenance, preventing water accumulation, and preventing curves, corners, or empty spaces difficult to reach and can be a gathering place for contamination and dust. The last 11th principles requires that sanitation is integrated into facility design. The design of building and facilities must be equipped with proper sanitation system in an integrated manner. We have to examine carefully each corner and grab to assure that the design encourages good sanitary practices, such as the design of the doors, sink, duct channel, and other things located near the walls to assure accessibility and cleanability. Meanwhile, for machines and equipment in food industry, there are 10 sanitary design principles listed in this slide. I will also go through one by one with each of these requirements. The first one is cleanable to microbiological level. As you see, machinery and equipment must be designed and constructed to ensure that cleaning and sanitation processes can be carried out effectively and efficiently. This process needs time, cleaning chemicals, water, and energy, thus reduced frequency is generally wanted. Continuous processing is one of the strategies that are done by industry to reduce the residence time, thus microorganism does not have enough time to grow and multiply. To assure this, it requires absence of area on the machinery and equipment where food products can stay for a period of time. For example, on a connection where sensors are installed, on dead areas, on the pump, valve, and others. The second principle requires that machine and equipment are made of compatible materials. All materials for machinery and equipment must have a surface that is inert, corrosion resistant, non-porous, and non-absorbent. In the United States, for example, for meat industry, all of the materials must obtain approval and be registered according to the guidance by the American Meat Institute. Steel material is the most commonly used materials, and the steel commonly used is stainless steel SS300 series. According to this guidance, materials not to be used are wood, enamel, and uncoated materials. The second principle also requires that composite, including plastic, must remain intact without changes in shape, structure, and function during cleaning and sanitation process. Painted or coated surfaces should not be used as food contact materials. Various metals used for construction of machinery and food processing equipment must be compatible with each other. Seals and O-rings must have a minimum contact with processed products, and materials in the construction of machinery or food processing equipment must be incompatible with the product's process, environmental condition, methods, and chemicals used for cleaning and sanitizing. The third principle requires that machine and equipment in food industries are accessible for inspection, maintenance, cleaning, and sanitation. All parts of machine and equipment must be easily accessible for inspection, maintenance, cleaning, and/or sanitation. The indicator for this is that the inspection must be able to be carried out by someone without the help of additional tools or machinery, and equipment must be easily disassembled. All contact areas with the product or product zone must be easily accessible for cleaning, sanitation, and inspection. For unreachable contact surface must be able for disassembly. If accessibility and or disassembly is not possible, then the equipment must be able to be cleaned with CIP, and if it is not possible, with COP. The requirement for accessibility does not only apply for the equipment itself, but also for parts attaching to or hanging to the equipment, machine or chain guard, or containers that belongs to the equipment, as well as belting system. In addition, all other surfaces other than food contact surfaces must also be easily accessible for cleaning and inspection. Equipment installation must have adequate floor clearance, usually 18 inches for each contact area or product conveyor, and 12 inches for equipment or machinery in general. The equipment or machine is placed at least 30 inches from the wall or overhead structures and 36 inches from one another. The fourth requirement stated no product or liquid collection occur in the machine or equipment. Machine and equipment, including piping system, must be designed to be self-draining. This self-draining design aims to minimize the chance of accumulation of residual products or cleaners and the risk of rust, especially when there is remain of liquid food, cleaners, sanitizer, or rinsing water on metal surfaces. The reason is because microorganisms can grow and develop in water, especially if there are remains of food products trapped in hidden internal gaps or pockets. The fifth principle requires that hollow areas are hermetically sealed. All holes or cavities in the machine or equipment must be closed tightly. Basins on machinery or equipment must be removed or permanently closed. Bolts, buttons, hangers, covers, junction boxes, plates, etc. must be welded such that they are part of the surface and minimize the possibility of accumulation or penetration of liquid entering into or to the surface of the machine, especially when accumulation occurs imperceptibly. And existence of hollow area has to be avoided early at the designing stage, and if this cannot be avoided, then it must be closed tightly. The sixth principle requires there is no niche, no crack, and no gaps on the machine and equipment. Food processing equipment shall not become gathering place for microorganisms or food residues. It has to be free of cracks, open connection, gaps, or dead ends. Therefore, it is very important to evaluate the welding quality and evaluate the machine and equipment when modification done to the equipment. The following are some important issues pertaining principles number 6, including the requirement for surface roughness for both food contact and non-food contact surfaces, requirement for corner and inner corners, no lap joints without hermetic closures, no caulking on food contact surfaces. All connection and welding has to be polished, and the use of fasteners is not recommended. And if it has to, fastening material must be made of the food contact materials. The seventh principle requires that machine and equipment has a sanitary operational performance. So during operation, machine and equipment must have a sanitary performance. That means do not contribute to insanitary condition. For example, spreading of food products, dust, entry of lubricants, etc. The following are important criteria for evaluating the principles. First, to ensure that various buttons or control panels are easy to clean. All pressurized air or air circulating on the surface of food product or food contact surfaces must be clean, filtered, and dry. Air must be dry to prevent condensation. Filter unit or to filter air should be placed as close as possible to food contact surfaces. The eighth principle requires the hygienic design of maintenance enclosures. Hygienic design for maintenance of protective caps for components such as electrical panel safety caps, chains, belt, etc., as well as protectors for buttons, valves, handles, faucet, etc. It has to be considered from the time of design and construction. Design and construction must ensure that the processed food products, water, or other liquid product will not splash and penetrate or accumulate in or on the surface of the safety cap and/or protector. In addition to consideration of quality and food safety, this also related with work safety. The ninth principle requires the hygienic compatibility with other plant systems. As we all know that various machines and equipment in food processing industry require additional systems such as exhaust system, drainage, etc. From the start, it must be designed so that the integration of various systems does not increase sanitation risk. Technical and detailed consideration need to be given for the design of exhaust duct, ability of the drainage channel to effectively dispose the effluent, the effectiveness of CIP system when integrated with certain machines and equipment. The design team needs to complete the checklist for the machines and equipment and other systems to allow the machine and equipment to function in the factory system. Lastly, the 10th principles for sanitary design for machine and equipment in food industry is validated cleaning and sanitizing protocols. Every machine and equipment for food industry must be equipped with a valid cleaning and sanitation procedures. The design and construction must be carried out by considering cleaning and sanitation procedures. The protocol has to be validated to ensure that cleaning and sanitation carried out in accordance with the protocol is both effective and efficient. The cleaning procedures must state the specification of the cleaners and sanitizer used in accordance with the equipment specification, operating conditions, and environmental requirements. For equipment industry to consult and collaborate with food industry or technology experts, especially food safety experts when designing, fabricating, constructing, and validating machinery and equipment for the food industry. That's all today's lecture on sanitary designs in food industry. You can visit the LMS to get more materials to study this topic. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.